Now, other than the basic gates and the universal gates, there are two other gates which are neither basic gates nor a universal gate, and these are an XOR gate, and the second is Xnor gate. Okay, now let's see XOR gate first. XOR gate is also known as XOR or exclusive OR gate. The property of a XOR gate is that if the number of ones at the input of an XOR gate is odd, then the output of XOR gate will be logic 1. Okay, see here an example. Suppose for a 3 input XOR, let us suppose there are 3 inputs and 1 output, and the inputs are A, B, C, where the output is Y. Okay, so if 0, 0, 0 is the input, then output will be 0. If 0, 0, 1 is there, then output will be 1. If 0, 1, 0 is the input combination, then output will be 1. If 0, 1, 1 is the input combination, then output will be 0. If 1, 0, 0 is the combination, then output will be 1, and so on. Okay, so you can see that for these combinations of input, the number of ones at the input is odd. Okay, therefore for odd number of ones at the input, the output is 1. Okay, now see another way. Let us take 2 input XOR gate. In a 2 input XOR gate, suppose these are the inputs and this is your output, A, B, 0, 0, 0, 1, 1, 0 and 1, 1. Okay, in that case the output will be 0, 1, 1, 0. So you can see the operation of XOR gate here. Now here For this combination, you can write for this 0, it is A bar, and for this 1, you can write B here. Similarly, for this combination, you can write A, and for this combination, you can write B bar. So in this way, for this output Y, you can write A bar B plus A B bar, and this is nothing the Boolean expression of two input XOR gate. Okay, you can also use its operator as a circle enclosing a plus sign between these two variables. Okay, this represents your XOR operation. Okay, so in this way, for a 3 input XOR gate, for 3 input XOR gate, the Y will be equal to A XOR B XOR C. Okay, so if we look at the symbol here, we find that the symbol of XOR gate is built using your OR gate. It resembles with the XOR OR gate symbol like this, however with a small slight difference between this. So this becomes a 2 input XOR gate. Okay, this is your XOR gate where this Y is the output and Y is equals to A XOR B. Okay, now let us see what is an Xnor gate. Xnor gate is also known as Xnor or exclusive NOR. Okay, the property of Xnor gate is that if even number of ones are present at the input, then output will be 1. Okay, that is, take an example here. Let us suppose these are, here we write input and here is the output, and there are 3 inputs A, B, C and 1 output. So for 0, 0, 0, output will be 1. For 0, 0, 1, output will be 0. For 0, 1, 0, output will be 0. For 0, 1, 1, output will be 1. For 1, 0, 0, output will be 0. And in the same way, if we can proceed further also. Okay, so you can see here that output is 1 for even number of ones at the input combination. Okay, and if we compare these two tables, that is this one, which is the table for 3 input XOR gate, then we find that this XOR gate and Xnor gates have the opposite outputs. Okay, so if we draw its symbol, then there is slight difference between symbolic representation of an XOR gate, that we can we have to use an inverter at the output of this XOR gate. This is A, this is B, and this is Y. Okay, now let us see its Boolean expression. For Boolean expression, consider a 2 input XOR gate, Xnor gate. For 2 input Xnor gate, if A and B are the inputs and Y is the output, okay, then for 0 0 input, output will be 1. For 0 1 input, output will be 0. For 1 0 input, output will be 0. And for 1 1, output will be 1. Okay, so in this case, you can see here this combination and this combination. For this combination, the expression will be A bar, B bar, and for this combination, the expression will be A, B. So the final expression for output Y will be equal to A bar, B bar plus A, B. Okay. The representation of a XNOR operation is like this. You have to encircle a dot between these two variables, and this represents Xnor operation. Okay. Please note that we have already know that XNOR is the opposite of, or you can say that inverted version of your XOR gate. So Y A XOR B bar will be equal to A XNOR B. Okay, or vice versa. Okay, now second point to note that about its application, these gates are actually used in case of parity generation or parity codes. Okay, so if there is an XOR gate, A, B, and if we apply a NOT gate at the input, at this position the value is A XOR B, at this position this will be A dot B. Okay, A XOR B. So the expression becomes, the symbol becomes this NOR symbol with this. This is your Xnor. Okay, y is equals to a Xnor